Okay, hello. Okay, I think everything's up and going. um, so for this first question, I think I already know what the answer is. Basically, wherever there's a t in this equation, we're gonna make it c times t, and then I'm gonna check it just by taking derivatives. Also, well, okay, I did also look at the Wikipedia page that has the solution involving the constant c. There's a constant. There's a division by c in front of the integral. I assume because of the chain rule with fundamental theorem calculus, but we're going to find out. Hey Rex, present plans will be successful. Nice. Um. Okay, so I guess let's start with uxx. Why not? Well, start with ux. Can we go straight to xx actually? How does fundamental theorem calculus work here? I need to look. I actually need to look at the statement. What about when there's like I'm confused when there's functions in the bounds. That's the thing that always gets me with fundamental theorem calculus. Oh wait, did I just get to the good part? Okay. I guess this is what I wanted to see. Oh wait, this is kind of weird. So we need to plug in the bound. Why is this u of x? Oh, I guess they're just trying to express this chain rule part. Okay, so If I'm not doing something stupid, which is always possible. Uh, Not really, Slim. I've been rewatching Rick and Morty. Well, rewatching. I've only seen up to I'd only seen up to season 6, and I'm currently partway through season 7. And then I've also started to watch Daredevil Born Again. I've only seen the first episode so far, though. I didn't know there's a new season coming. I just kind of felt like watching it. Okay, because we're doing derivatives in X, I don't think anything special happens with chain rule here. So I guess UXX is going to be really similar. Oh, okay. Yeah, I know that there's a different voice actor for Rick, I think starting in season 7, and I didn't really even notice. I think whoever used to voice act for Rick turned out to be like a problematic person. I don't remember exactly what the old voice actor did. Oh, okay. G and H are not functions of T. You got a little cancel the voices mostly the same. You can tell a little. Okay, yeah. I'm sure if I looked for it, I could hear a difference, but I didn't like notice it or organically. So that's I guess about as much as you can ask for when there's a voice actor change. Oh wait, I just said that G is not a function of T. Well, I guess this that no, okay, never mind. It's G of X plus T. Zach, thank you very much for the raid. How's your stream? Um, just working on this homework problem about we actually just finished talking about the wave equation in my PDEs class. And so this is homework all about the wave equation. So we're starting off just we only ever talked about because this is a math class, we only ever talked about C equals 1. And this question is just about modifying it for a general C. I just took the answer from the Wikipedia page because I've already seen this before. Hey, $5. I'm working through this. I'm so bad at using the fundamental theorem of calculus for when the bounds have functions. And in integrals, that's the main thing that I'm dealing with right now. And so this thing I'm taking the derivative, or yeah, so it's going to be h of x plus ct, and then chain rule, so we're going to multiply it by c, not t, not y. And then, is that a minus? Or should that be a plus? I think it's a minus. Yeah, it should be a minus because it's the lower bound. So the bounds have functions right as a composition where the outside function is integral from 0 to x. Oh. I guess, yeah, that's smart. Mega. I pulled up a random. I just like Googled fundamental theorem calculus and was matching what this example problem was doing, basically. That is probably a nicer way of doing it. My boomerang won't come back? That's funny. Okay, so Jed, congrats on the first. Okay, so this would be a minus, but there's another minus because of the chain rule, so I'm going to make it a plus. And then let's get UTT. C squared GTT. Oh, wait, another sign flip. Oh, wait, I see where the cancellations are going to happen now. So I was wondering how these cancellations, like how this is ever going to resolve itself. But doesn't G sub T equal H? Or am I crazy? That feels weird though. If G like, it's like we're losing a degree of freedom. I don't know. Let's just write this out first and then add everything up and see what must be true. 1 over 2c c squared ht x plus ct minus c squared ht x minus ct. Okay. So we're going to take UTT. Ugh, this is too many letters. Minus C times UXX. And hope this thing equals 0. We take our lives, they can never take our degrees of freedom. Yeah, it's just weird because I've always thought of G and H as being general functions. And so I'm worried that I'm misunderstanding something. But it does seem like if you take the derivative with respect to t of each side here, it should be that G sub t equals H. Actually, I wonder if this is the textbook. Do they do this calculation? Okay, let's get, I guess, part 2 of this theorem. Oh. What? The proof is a straightforward calculation. Okay. Thanks, book. Number e to the 2I pi today, that's true. Okay. Well, that's good. So on my homework, I will now write the proof is a straightforward calculation. Because that's just acceptable to do, apparently. Dropped an X. These should all cancel out some way, somehow. Is there a relationship between GXX and GTT? Yeah, I mean, it's linear in both terms. I feel like, can we convert a derivative of one to a derivative of the other? Like if you have d by dx of some general function f of x plus ct, shouldn't it be the same thing to do 1 over c d by dt f of x plus ct, question mark? How do I justify this? Like, I think this should be true. Well, I guess this is kind of the point of the wave equation, I guess. These derivatives are equal. But I guess this doesn't exactly make sense, does it? Because if I literally have my function as x plus ct, we don't get the same thing. We get different. I think these like dummy variables, and we do get different dummy variables out of this. So never mind. Hey, color cone. Hmm. What is the relation I'm supposed to make here? Does the Wikipedia page go through this? I think it shouldn't be that hard. Time to draw a triangle? Why would a triangle help? Do we know anything like maybe taking these derivatives aren't equivalent, but like mm, thank you for the 30 streak. We have equation solution with sustained mechanism or whatever. Yeah, I'm just trying to figure out something that should be pretty simple about the wave equation. Like we're basically we're just given this for D'Alembert's formula, and the question is just to generalize it for when you have or like ugh, when you have a constant that isn't 1 in front of the second derivative in x. Oh, you know what? Okay, so maybe the issue. So before I was wondering why like I can't take derivative with respect to time of each side on this equation to say g sub t equals h, but these aren't functions of time. I think I would just get zeros, and that's what the reason why you can't do that. Then how do you get these things to cancel? Like they should cancel. What is the h bit? H is the initial condition for the derivative of u in t. It's like my primary problem was just to start with this formula and prove that it's the right one by taking derivatives. I may have made a mistake in my derivative calculations, but even if I did, there's got to be some sort of realization we need to make with how the derivative in t relates to the derivative in x. Like I feel like there has to be a relationship there. Really, Annius? Um, so I'll write it again. Just for some general function f, I want to say that this is true. But the thing, I just like let f uh, be x plus ct, and then if you actually do these derivatives... Oh, wait. I did the derivatives wrong. That was my problem. I got something weird like x equals 1 over ct or something, but I just don't know how to take derivatives, I think. Because if you take a derivative with respect to x here, I guess I'm thinking of it as like a partial derivative. Um, it would be 1 equals 1. Okay, so maybe that is good. I feel like that there should be some better way to justify this. It's probably I guess it's just a... Well, I don't know how to explain this. I just think this true intuitively. I don't know how you talk about that more formally, though. Um, let's just go with it, though. That in green. So let's turn everything into derivatives in x, I guess. Okay, I was wondering what you just DM'd me. That answers that. I'll look at it once I'm done with this problem. Shoot, why am I doing this? So we have, well, isn't this going the wrong way? Like, am I about to get a c to the 4th here if I apply this identity? And that's bad. Um, what's going wrong here? Like, there's no way this should be a c and not 1 over c. But I'm getting the... C gives me the right answer, I think. Actually, no, my powers are still off. Did I mess something else up? Kim Kardashian? I don't know. So we already have a c squared here. If I turn this GTT into GXX, it's going to be a c to the 4th is my issue. And this c to the fourth gxx is certainly not going to cancel with this c to the 1 gxx. This is the original problem here. What the hell is this, Desson? Okay. What is this problem? There must be some simplification here. Because, like, this problem looks very... This problem down here... Oh, it's going to be x over sine x. Never mind. Cyclotomic polynomial... I don't know, maybe. This looks like... What the... Oh my god. Okay, we'll look at this more. I still want to figure out this wave equation. But those problems could be interesting. Okay, proving D'Alembert's formula by taking derivatives. Surely someone has done this on Stack Exchange. This isn't Stack Exchange, but let's... Oh, hey, this is the exact problem that I'm trying to do. No, it's not, but we can at least check my fundamental theorem of calculusing. Why are you using primes to denote two different types of derivatives? What? F is a function of one variable? I guess that's true. Maybe I should have written it like that from the get-go. Is that my problem? And I shouldn't do this conversion at the end? But do I still need to remember that it's an X, like... Would this work? Okay, let me try and work this out mentally. This should still be the same as this, I think. Just with primes instead of t's. I mean, okay, no, I'm still... My powers of c's are still off. I still have a c squared here, and I'm only going to have a c here. You don't think GTT makes sense? You're probably right. G is a function of u or some other. I just don't know what that means when, well, I don't know what it means for like, what am I doing to each side of the equation? If I take d by dx of each side, and I get to g on the right-hand side, I don't know how to convert that, I guess. G of u is u squared. Too much computation for me too. I mean, I think the test you sent me is even more computation. Yeah, it's D'Alembert's formula. I'm trying to prove it satisfies the wave equation. Well, okay, now let's be explicit. But like, I we're doing a change of variables. That's the thing that I didn't connect. This? This is all sorts of wrong. I, yeah, it should be times C, but like, oh, hey, VFX edits. Probably, but that's okay. You know what? This isn't du dt. This is du dt. It's not d by du. Or I don't know what I'm saying. Chen Lu? I don't know what that is. A Chinese figure skater. I don't know how to use it. I can't say I know how to use Chen Lu. Doesn't sound ethical. So sure, I think my result is still correct though. Like that helps me explain like why it's this, but I still don't know why we're not getting the right cancellations. Oh, it's the chain rule. Okay, okay. I haven't watched Black Pen Red Pen in a minute. I do really like his stuff though. Well, I don't know what else it would be. So what is supposed to cancel out? Well, I'm gonna I'm about to do UTT minus C times UXX. Um, the H's are fine. Like these right terms are fine. It's a lot of circles. It's just the G's that I apparently messed something up on. I'm off by I need either this to be just C or for there to be an extra C in front here. I'm supposed to get square root C? Am I? Wait, is it C squared? Did I not look at the original thing? Fuck me, it's C squared. Okay. Thank you. So my H's might get messed up now, but we'll see. Are these all root C's? They are. Okay. I'm I'm fixing the stuff out of order, and I'm gonna forget to fix something, but who cares? Okay, is that everything? I should probably keep that because I'm going to get confused later. Okay. 1/2 CG double prime minus 1/2 CG double prime. 1/2 CG double prime. Good, good, good. This all cancels. Okay, life is better. Okay, I did promise this and I would... Well, wait. Speed of propagation depend on C. The speed of propagation is root C. Okay, that's number 1 answered. We have 4 more problems. That'll be a lot harder. I think that one was just supposed to be an easy one. But we'll look at Destin's thing first. 110 minutes. Find the following integral. I found it. It's right here. They should have said evaluate. Denmark said something about cyclotomic polynomials. Oh, if the sign is alternating? It's Chen Lu again? I should have known. So the point is these should factor really easily, I guess, into roots of unity? Phi sub 6. And phi sub 6 is also that. How does that make sense? Isn't this a 6th degree polynomial? And that's only 2nd degree? They're not needed? Well, I'm not doing this by hand. Actually, I guess this one probably is not cyclotomic anyway, or that one. Are there any non-1 coefficients? No. Okay. There is a weird sort of symmetry where the coefficient of these is 1 more than the exponent. Looks like a derivative, I guess. Oh, is it integration by parts? It's still a pain if it's integration by parts. Are they for real with that one? Is that a joke about cyclotomic polynomials, Yanis? I don't know how I have no clue with this. I don't know. I don't know, Zach. Fully into the algebra direction now. You're gonna have to do an integral again. There you go. You don't have to worry about stuff like this. I'm interested in the third one. We can look at just the third one then. Because number 2 looks like a contour integral to me, but I assume it's not a contour. And I assume you're not intended to do contour integral, which means it's probably Feynman. Parallel has so much in common, but they'll never be able to meet GI. You know, I never thought of parallel lines like that, but that is pretty tragic. Oh wait, we're given hints. Are these... How are these organized? Like, is this hint only... Are these hints only for number 3? Because the second hint... I think it's the... I think these hints are all related to this one part problem. Express ln 1 over x as a Maclaurin series. Yeah, it's kind of funny. They say let f of x equals this, but f of x never appears down here, does it? What is the power series for ln? Common Taylor series. X minus x squared over 2. Okay. Multiply 2 series and use the definite integral. Oh, this is gonna be a Riemann sum trick. Multiply 2 series. I assume we're gonna square this series? There's the Cauchy product formula for stuff like this. Could also just write out the first few terms. Let's just do that and look for a new pattern. So we'll have x times x that gives us an x squared. How we can make x cubed by doing that times that. And we have 2 different ways that that occurs. So it becomes minus x cubed. Oh, is it gonna... Wow, do these coefficients actually clean up? I feel like it's gonna be a factorial. I don't think they'll clean up. Okay, how many ways do we make x to the 4th? We can do that times that twice. Or we can do this squared once. So x to the 4th over 3 times 2 plus x to the 4 over 4. It's not cleaning up how I hoped it would. The box method? I don't think I know the box method. At least not by that name. Let's do one more power. Shoot, what is this coefficient though? That gets times 4, which is 8, times 3, 11. Well, that's painful. I'm not missing an x to the 4th. Oh, I am missing an x to the... No, I'm not. There's... Oh. I mean, it's kind of weird for infinite sums. I guess there's no reason we can't do this. Um... Okay, and so we're going to be summing along these diagonals. Oh, I was off to a terrible start. Oh yeah, I think I've heard that. This is basically a convolution. Do we have any other ways to make... Yeah, we're gonna have 2 other ways to make x to the 5th. So let's go out one more. Wait. This might be one of those ones where it's actually less helpful to do all this addition. Okay, well, actually, no, never mind, it is helpful because the pattern looks kind of clear now. Um, the first term, wait, no, I'm doing something terribly wrong. $12 is 4 factorial. Is that... Oh. Should I not have reduced these? I think it was a bad idea to reduce these fractions. $12, 8, 20. Never mind, I don't know what this pattern is. 3, 12, 24. This might not even be the right step. Like, they said multiply 2 series without being specific. There could be some other series that we're supposed to multiply here too. Like, what's the actual goal? I wonder if... I mean, could you start writing out terms of this and rearrange it? Also, let a be greater than 0. Where is a? I don't even see a down here. I don't know. I'm kind of getting towards wanting to just walk away from this problem. There might be a more clever series we're supposed to multiply by. What else is on this test? Oh, it's only... This is the end of it here. So let's just see what number 4 is. Just out of curiosity. 0, 1 squared to r. It's like a 2-dimensional Dirichlet function, if I'm thinking of the right name. It's like a final exam problem you had once for real analysis. Number 4 here, or the one we were just looking at? Number 4? Okay. Okay, so this just gives us how we're forming our grid, I guess. Define the upper Riemann sum. Hey, this is a Darboux sum. Prove that the upper sum is equal to 1. Huh. This feels like an introduction to like the whole Lebesgue integral thing. Yeah, Destin. Yeah, because we're just adding up n squared many subrectangles, n squared many times. And each has area 1 over n squared. So I feel like A and B are actually kind of quick. Conclude that f is not Riemann integrable on 0, 1 squared. Since the limit as n goes to infinity of this does not equal limit as n goes to infinity on that. Now this is the part that I don't know. Oh, actually, yeah, no, we can claim that capital Mij is always equal to 1, and lowercase mij is always equal to 0, no matter what ij are. So it's just 0 is not equal to 1. Yeah, as Fembuck says. So actually, I'm surprised that this is the only problem that I think I can actually do off this test. Yeah, the two-dimensional nature of this really doesn't add anything to the problem, I don't think. They're just trying to trick you, I think. 0 is not 1. Don't let Terrence Howard hear you true. You know, it's been a minute since we've thrown some Terrence Howard jokes in there. For these other three up here, I gotta think they want you to do Feynman for number 2, and I don't want to do Feynman. I bet I could contour integral it, but I don't feel like doing that. Oh wait. Can you do a U sub? What would the U sub give? No, never mind. I wanted to do U sub with 1 plus cosine squared. We wouldn't be able to deal with this x though. That would be messy. I saw that. I call bullshit though. At least for this being a normal introduction to integral calculus class. Yeah, it's like I was talking about that, but you're gonna get an inverse cosine, and I assume that's a non-starter. Maybe there's a way to deal with that. And you maybe then integrate that by parts, but I think that's not going to help. Because you're going to get tangent over root 1 minus u squared. I think. Will that be in the integral, or will that be the boundary term? Yeah, I think you're going to have to integrate inverse tangent divided by root 1 minus u squared if you integrate by parts. Okay, well, I'm happy I at least solved one of these problems. The first three, I have no clue. I think I want to go back to the wave equation though. That's true. The next question after this is a series, and this is also a series, which is a finite one. So maybe they want you to do power series down here too. Like you could reduce this to the integral of x over sine of x. I don't think that's helpful. Hey, BV cleanse. This is I I I I don't know. This is like competition type math. It feels like it's apparently an exam for a second semester calculus class, but you don't do stuff like this in a normal calculus class. Did you memorize the solution? Hey, Energy. It's been a minute. I hope you've been well. Okay. So yeah, thanks for sharing, Dustin. I think I'm gonna stop with this though. Uh, feel free to ask it, Energy. I don't know if I can answer it, but you're welcome to ask it. Recently I heard about ultrafinitism. Here's if the Church-Turing thesis refutes it. Do some Googling. Ultrafinitism. I'm done with my semester. I'm in summer now. Any websites, things you recommend so I get ready for my pre-calc class next semester? If you want a full-on textbook, I think Stack Exchange is the place to go. It's free. They have free and legal. Sorry, not Stack Exchange. What's the name of this? OpenStax. These textbooks are free and legal, and they go from like the most basic math all the way up through calculus. So I would pull, I guess, their pre-calc book. If you want something that's a little briefer, if I haven't already told you about it, Paul's Online Notes does have a section on pre-calc. Like this algebra and trig review part, or this algebra part up here, will be pre-calc stuff, even though he calls it algebra. Those things that come to mind. Yeah, it's a good idea. Just to like get ready ahead of time. Same from the toughest university. Same exam has the toughest math exam in Latin America. Oh wow. Ultrafinitism, ultra-intuitionism, strict formalism, strict finitism, actualism, predictivism, and strong finitism are various philosophies of mathematics with aspects of finitism and intuitionism. Common to these philosophies is their objection to the totality of number theoretic functions like exponentiation over natural numbers. Really? The only actualism I appreciate is actual educationism. I assume you mean informal, Dessen, but that's exactly why I like it. I like having an informal resource. Okay, so they object to the idea that you can define a function like exponentiation over all of the natural numbers. Like there are some natural numbers that you can't raise to a power, apparently. And that sounds like what it must have to be, Energy. They deny the existence of the infinite set n of natural numbers on the basis it can never be completed. Well, that's My gut feelings to say that that's stupid, but okay. um, some ultrafinities are concerned with acceptance objects in mathematics no one can construct in practice because of physical restrictions in constructing large finite mathematical objects. The floor of the first skews number. Never heard of that one. Yeah, this is very physical. I like that description of Flofi. NCAT I don't know what that is. Okay, so we at least have the most basic version of what ultrafinitism is. Let's look at the second part of what Energy asked about, which is the Church-Turing thesis. In computability theory, Church-Turing thesis is a thesis about the nature of computable functions. It states that a function on the natural numbers can be calculated by an effective method if and only if it is computable by a Turing machine. The someone said, I want to be a vacuum cleaner? Okay, whatever that means. Like notes that only show sketches and graph representation of theorems. Is that not informal, doesn't? Oh wait, so maybe you are saying that puzzle notes is too formal. You want it to be less formal than art is? It is a lot of art. I did seed it with an Arctic Monkey song. Most of the time, opening NCAT Lab to look something up feels like someone's screening you buzzwords. So this definitely feels related to the ultrafinitism, or like, you know, in opposition to it. Reference computed by paper and pencil methods. So actually, maybe it doesn't. Maybe these are compatible. We need to know what... I don't know. How practical is ultrafinitism? Because there is no number you couldn't write down if you had enough paper and enough pencils. Maybe I never would do it, but I could do it if I wanted to. Me theorem definition done, I will format it the way I like it. Okay. How about just the maximum value principle for harmonic functions? Think the alcohol poisoning? Don't know if they're compatible because Busy Beaver number defined using Turing machines. They get big, so the ultrafinists probably not accept them. The thesis says any effective method of functions involving the natural numbers can be performed. Yeah, we need to know what an effective method is, and I don't know what, like, I know of Turing machines. I don't remember what they really are, though. Finite time deterministic procedure for solving a problem from a specific class. So it may be a very large time. So I think the issue is that, like, for me, finite is good enough, but for ultra finitus, it's not good enough. It needs to be small, which is why I think they could be compatible. They're just talking about different things. A Turing machine is a machine that shows you around town. That's a Turing machine. I'm trying to think of something else that Turing sounds like. No, a Turing machine is a machine that gives you two pieces of jewelry. A Turing machine is a bus. That's true. So my immediate question for an ultrafinitist is, has the floor of what numbers we're allowed to use increased as technology has come farther? Like, as computers get more memory or as resources become less scarce, are we allowed to use bigger numbers now that we can write them down? Hey, Winklebot. The argument I'm making is that if the thesis is true, that in principle, any function involving finite natural numbers can be performed over time by a Turing machine. Principles methodologies exist because they're computable. Yeah, energy. I'm inclined to agree with you. I just think that ultrafinitists aren't talking about. I think they understand that, and they still. I mean, I've read 3 paragraphs from a Wikipedia page, so don't take my word for it. But I would guess an ultrafinitist would understand that and still feel the way that they feel, because even though you could compute it by a deterministic algorithm, you're never actually going to. Like, you're going to die before that happens, or you're going to run out of paper or something. So that's why I think they might be compatible. But I do agree with you. Like, this doesn't. I don't know why you would want to feel like this. This feels very like a very limited way of thinking. Winklebot, we're talking about and this is like a philosophy idea that Energy DeHamter brought up called ultrafinitism. It seems to be people who feel that you shouldn't be allowed to use numbers that are so big that you can't write them down. So an example of number you shouldn't be allowed to use is this first Scuses number, which is e to the e to the e to the 79. And Energy is wondering if a good response to this idea, because it's I think to both of us it sounds kind of weird and maybe not useful, but we're talking about the church Turing thesis as a way of kind of trying to defeat it. I'm skeptical of this thing. I'm skeptical that it would, but this does match how I think about math a lot more than ultrafinitism. If n is a natural number, is n plus 1 also a natural number? That's a really good question, Mega. So yes, but you would die before you get to every natural number. Natural numbers are the ones you can actually get to. Skews numbers, probably not one of those. Induction is obviating the need to actually realize all yeah, oh, that's a good... Yeah, Floppy. They probably would disagree with the idea of induction also. Ultrafinitists accept the US national debt as a number. That's funny. How formalized was set theory when all this came up? I don't know. How modern is this? At least as old as 1988, so fairly recent. Let me see what Kevin sent me. Oh yeah, so I'm gonna take a quick aside to look at what how Kevin thinks about the maximum value principle or harmonic functions, and then we'll come back to ultrafinitism. So this is how Destin would prefer a diagram like this to a formal statement like what's on top, I think, is the point. If K is a compact, non-empty set that is a subset of some larger domain U, then F evaluated at K maps to either the min or the max on the boundary. If U is equal, maybe the closure of U? F, or if U is a closed set, I guess. And K is compact. So F evaluated on this compact subset. Oh, if U is open, because it's an O, I get it. If U is an open set, haha. I never seen that notation, but I like it. F evaluated on a compact subset of this open set cannot attain a maximum or a minimum, or it's constant trivially. Okay. I personally, words would have done the same job as this for me, but this is a nice way of thinking about it too. Like when you said with like pictures, I was imagining more like an actual like sketch of a plot, I guess. Okay, let's get back to ultrafinitism. UO's the interior. Oh, maybe. Like if if you have a compact set, UO would be the set minus its boundary. Like instead of the closure was set, the open sure. Okay. Let me catch up with the earlier chats. And so I guess in 1988, set theory is pretty set in stone to answer Winkelbot's question, I think. That's the fundamentals. Someday I think we might be have that number in debt. True. Which I'm thinking about is that I've been learning Euclidean geometry recently. What other background should I have for learning Riemannian geometry? I don't know anything about Riemannian geometry. I think there's something that's really difficult though. Let me. I will Google that, but I also want to get through the other comments about ultrafinitism. So Flofi says they don't disagree with induction; they disagree with the fact that it proves things for all natural numbers. Yeah, okay, that's what I meant, Flofi. Like as it goes off to infinity, they disagree with induction after a point. Like you can only induct for finitely many cases. Learning about arc lengths and maybe some trig, you'll need some ability to calculate arc lengths. Oh, for Riemannian geometry? Winkelbot? Maybe. The open sure, the largest set contained in it. Yeah. Connect, do you like having that notation? It is true in general that UO equals U slash delta U. Okay. Reinduction, note that if you disagree, those numbers that induction doesn't hit exist. Fair, yeah. Fluffy. It's better to have already done differential geometry before getting into Riemannian geometry. When you read words, they make me do two things. First, understand the words, get distracted with it. Yeah, I mean, I definitely, I do need to process things. Like when I first read a definition in words, I do need to like take a while to like process it, I guess. The words they don't immediately make everything perfectly clear. Riemannian geometry. So I think Energy has mentioned previously wanting to talk about general relativity. And that's the angle that they're interested in Riemannian geometry from. And so as Colorcom says, I guess you want to know differential geometry first. And differential geometry, it's like calculus 4, like as I think it was like the fourth semester of a calculus class. So you want to learn basic derivatives, basic integrals, multivariable calculus, and then differential geometry, and then Riemannian geometry. It sounds like maybe you can skip around a bit, and you wouldn't lose too much. But yeah, I mean, you don't have to like go through the path that I just said if you don't want to. You could try to go straight to Riemannian geometry and just see where you get confused and then back up and like you could work backwards. Like you don't have to follow this beaten path. IDK bro, I'm fucked. Yeah, sure. Feel free to put it in the Twitch chat here if you can put it, or my Discord. You can put screenshots and stuff. Welcome in. When you read words, they make me do two things. First, understand the words. Oh yeah, okay, I already read that. You like doing math out of order. Like I read math, that's way too advanced for me. Try to struggle with it. Then go back and try to do the prerequisites, rinse and repeat. Yeah, and so that makes you actually appreciate the prerequisites more and not get bored with them because you have a motivation. So I wouldn't, if you want to go straight to Riemannian geometry, like do it, but don't expect to succeed. It'll still be a useful experience though. It just depends on how you think. You can do a course on embedded surface, talk about Gauss curvature if you want a quick start before investing too much time in that project. Okay. Pushing up pre-calculus in college, you took linear algebra in high school. Okay, that'll help. Yeah, you definitely... It would be hard to not know calculus and get into this, so... I would try to go through at least some... I just like the concepts of, like, single variable calculus, if nothing else. Very gentle touch of general topology, just 2 or 3 definitions. Okay. You're trying to do graph theory summer as a side project. You don't have any math this summer. You have a few topics you want to hit. Ooh, nice, nice. Graph theory is cool. My goal is to write a book completely made out of Manin with hyperlinks. Ooh, that's cool. Dessen. Guaranteed differential geometry, differential and integral calculus. Yeah, fluffy. Graph theory. It's in a part of math called discrete math. It's all about like representing networks. So in graph theory, you talk about nodes and edges. So a node is just a point, an edge is a line that connects two nodes. And you can have graphs that, honestly, you don't really even care about the shape of the graph itself, but you just have some nodes and some connections, and you could rearrange these in any kind of, like the physical location of these nodes isn't actually relevant. And as Winkelbot says, like the thing that kind of kicked off the study math is the bridges of Königsberg. It's a famous problem. I think Veritasium has a video about it, if not also 3 Blue 1 Brown. And so it's a really powerful thing because this represents networks. Like nodes could be computers and the edges could be the internet connection between them. Nodes could be cities, and the edges are the distance between those cities. And like there's another classic problem called the traveling salesman problem, where you want to visit all of these cities, and what is the cheapest path between them? I think the difficulty is that it becomes difficult to compute very quickly. And so yeah, like train tracks, as Winkelbot says. A really cool use for it that I only learned about a few months ago is oh shoot, how are these represented? You can use these in machine learning. If you're interested in like unsupervised learning, in clustering, you can think of your nodes as data points and the edges as kind of how similar those data points are. And you can make some sort of like cutoff for if they're not similar enough, you just sever those edges. So let's say like our data looks like this, and there's some really weak edge connecting these two. You could make a machine learning algorithm by just deciding to sever this edge, and you now have two distinct clusters So that's a cool thing to do with it too. You find it very underwhelming learning Riemann geometry. You end up playing a lot of indices, and the cooler stuff are locked behind even more functional analysis. It's very useful for geometry in general. Functional analysis, resident sleeper. I think the main thing is to get the three big calc, theorems, Green-Stokes divergence. Three-phase differential forms, where it's a lot easier if you know tensor algebras. After that, you don't think there's a good idea in differential geometry. Okay. I found was a really cool video on graph reconstruction that was super neat. I think I should notes you need to reconstruct a graph. Ooh, okay. Okay. Oh, who was asking to post a question? Did I miss that? IDK bro, I'm fucked. Wait, let me just... Okay. I haven't seen your problem yet, so I'm gonna keep on yapping. Let me find that Veritasium video, because it was a really cool one. Veritasium... What was it called? It was about roads. I'm just gonna search Veritasium graph theory and see what comes up. I don't know. Yes, that's the exact video that I'm thinking of, Mega. And Veritasium changes his thumbnails and titles all the time, so whatever it was when I watched it, it's probably changed since. It might be this one. No, this is about Girdle. Never mind. I don't think it was Markov. Oh, this is also a cool video. Oh, no, that's not very I don't know. I can't find it. Eldritch, it's not my birthday, but thank you. I read about quivers. I think so. Gabriel's theorem. The quivers, like, doesn't it have to do with vector fields? Oh no, it just has a bunch of arrows. That's why they call it a quiver, I guess. Another name for a multi-digraph. Right. They just call it a quiver because of all these arrows. I assume. Maybe you also quivered when you learned about them. There's a forgetful functor from cat to quiv. What a sentence this is. If you knew nothing about math, that would... And, like, just say that sentence to a stranger on the street and see how they react with no context. The kind of sentence you like, Yanis? Classifies quivers of finite type in terms of Denkin diagrams? If it has only finite many isomorphism classes of indecomposable representations. Okay, sure. Whatever that means. Category coherent sheaves on a QC-QS scheme recover the scheme. Sure. You did a course on this, Flippy? Oh, nice. Okay. IDK, bro, I'm fucked. Let's see. If x is equal to square root of 3 plus 2 root 2, then find the value of 2x cubed minus x squared minus 8x plus 120. Okay, we can do this. Peter Gabriel's theorem about what happens if you do gradient descent on Salisbury Hill. I think I've heard of that one. That sounds really strange, just a sentence. You can use them to get the classification of semi-simple finite type Lie algebras. Oh god. Yeah, Winklebot. Math words get first root as whole root. Oh, it's like, okay. It's like this? Okay. You're hyped. I like it. Okay, so we know what x is, so let's just plug this bad boy into these x's here and see what pops out. So we're gonna get 2. And also, I'm gonna rewrite this big square root. It's the same thing as an exponent of 1/2. So I'm gonna equivalently say this. Squared minus 8. 3 plus 2 root 2 to the 1/2 plus 120. This is going to be a pain. Please correct me if I'm mistaken. My understanding that machine learning utilizes probability theory and Monte Carlo methods. It definitely uses a lot of probability theory. I think Monte Carlo method is for simulations, though. I'm not sure that machine learning would use them. But there's a lot of probability, for sure. I may be misremembering what Monte Carlo is. But okay, so I'm going to use a property of exponents, which is if you have some number a, well, I guess don't put value of x, try other way around. What do you mean other way around? What are the ways there? Can you write Carlos that doesn't have to? I don't know if I'll sit in it for next semester. Monte Carlo methods are popular in RL, like Monte Carlo tree search. Okay. There's a different method that use identities. I don't know how else you could possibly do this besides plugging x in. I'm gonna keep on going because I don't quite know what you mean. But basically, we have a power to a power here. Like, we have to the power of 1/2 and then to the power of 3. And so there's exponent rules that say these numbers will multiply. So it's going to be to the power of 3 divided by 2 is how we can simplify that. And now we have 2 times 1/2 is just 1. And raising something to the power of 1 isn't doing, like, this 1 doesn't really do much, so I'm just going to erase it because it's the same thing. And then I'm not going to change anything in the last part of the problem. Okay, so I would say from here on out, it's kind of a matter of taste for how we want to simplify it. I want to group this term with this term and this term with this term because the green terms are kind of cleaner and the blue terms are messier. So I'm also... Okay, yeah, so... remember, we have a minus sign out front here that gets distributed to each of these numbers. So it's like -3 plus 120 is 117. And then we have a minus 2 root 2 is how our green terms clean up. Now the blue terms, I'm going to factor out a 3 plus 2 root 2 to the 1/2 because we're allowed to do that. So 3 plus 2 root 2 to the 1/2. What gets left over inside from this first term, we have a 2 times this thing cubed. And then from here, it's just a minus 8. And so that's what happens to our blue terms. So the only thing I really want to do now is multiply out this cubed and kind of group things up. And I was just wondering if IDKBR wanted to factor this first, which could maybe save work. I don't think it'll save that much work though, if it does. What am I missing in chat? If you've heard of Alexander Kirillov, okay, yeah. The book has some great exercises, some super computational. Shane, hello. Never following rules and everything. This always looks like magic. It is magic to like know what to do, because like the hard I'm so terrible with words. It's just the most difficult thing with math is knowing what to do, I feel like. I hope you're doing well though, Shane. It's an 11th grade question. This is pretty difficult for 11th grade. I mean, I guess it's a lot of, it's kind of tedious for 11th grade, I'd say. Night Gasper, hello, welcome in. The original question is, we're given x equals this, and we have to find what this equals. That's all the question is. So maybe there's a more clever way. I don't really see it, so I'm just kind of going for it. We can factor 8 out? Like x minus 8 is a root? Is that what you're saying, Winklebot? On the step we're on? I don't think I want to factor an 8 out. Do I? Oh, I see. There's an 8 hidden inside of here. I'd rather not. We definitely could. Well, that'll give us a fraction. I don't know. I don't want to do that. First day of summer, having Goblin Day. Ooh. That Goblin days are good days. I hope you enjoy, Shane. Okay, I'm gonna do something on the side here. I need another color. I'm gonna write this thing cubed as 3 plus 2 root 2 3 times. And then I'm going to multiply like these two things out. That's what I'm doing in this step here. So this 3 plus 2 root 2 is just that first one. And then when I multiply these, we get a 9 plus 6 root 2 plus 6 root 2 plus 4 times root 2 squared is just 2. Okay. And so in the middle, this will clean up to be a 12 root 2. That 9 stays put, and that becomes an 8. And so the 9 and the 8 group together to be a 17. The more thing of this problem than you've done all day. I mean, You need breaks from thinking. Awesome. I'm glad this is helping so far. IDK, bro. Okay, so I'm gonna now multiply this times this. So 3 times 17 is annoying. 51? I guess so, 51. 3 times 12 root 2 is 36 root 2. What a terrible 36 root 2, by the way. 2 root 2 times 17 is 34 root 2. 2 root 2 times 12 root 2 is 24 times 2. Minus 8. We're almost there. Disgusting. It is pretty disgusting. Okay. The geometric center is a construction obtained as a composition of two functors. First Rosenberg spectrum, whatever that means. 3 times 19 is slightly more annoying. It is. That's the Grothendieck prime, right? You can put it in like math discussion if you want. If you're in the Discord. $51 plus 48. 99? $36 plus 34, 70. Okay. And then I'm going to take this 2 and multiply it into each of these. 99 times 2 is 198. 70 times 2 is 140. What time is it? Okay. Okay. Now we just need to do 198 minus 8, and I think we're home free. 190 plus 140 root 2. I mean, we could simplify this a little more. We could factor a 10 and put it in front. I think that's all we can do. $19 plus 14. It doesn't even clean up in some satisfying way. I don't like this is this just feels wrong. I guess this is the answer that I get at least. It does not, Shane. This is just some tedious, busy work that IDK Bro and Fluct got assigned, I think. I don't know that you really learn all that much by doing this problem. Or at least you could learn whatever this problem teaches you without as much pain. Okay, but yeah, let me know if there's anything else IDK Bro and Fluct. If you post the solutions somewhere, let me know, but maybe I don't know what real world situation this would be, but maybe. But yeah, since both IDK Bro and Fluct and Night Gaspard, I see you're both new around here. Whenever I do see a new person, I do like to let them know that there's a whole niche of math streamers on Twitch. It's small, but this niche exists, so I encourage you to, if I'm ever like not around and you need help or you want to just talk about math, just take a look around, and there's a whole bunch of other people who do this thing too. Thanks for the follow, Night Gaspard. The real situation of sadistic maths program. Yeah. I did have one math teacher, like whenever someone asked him when would we use this in real life, he'll just say, in case you ever become a math teacher, you need something to torture your students with. Try to join your Discord. Sounds good. I mean, he said it in like a smiling way. Like he knew that the stuff he was teaching, like it's at least like difficult to answer that question of when you would use this in real life. And the question isn't entirely fair, I don't think. But yeah, like I think it was just teaching stuff that he had to teach. Like he probably kind of agreed with that sentiment to some extent. On the exam on Tuesday, yeah. Okay, so IDK bro, I'm fucked. Once you upload it, I'll take a look at it. In the meantime, I'm gonna go back to doing some homework problems, but once I see it, I'll switch back. Oh. Okay. Computer science / algebra god. Ooh, that was a good yeah, the Monte Carlo method for like does that get used in machine learning? I don't remember what the Monte Carlo method even is. Use it today on stream. Oh yeah, I saw you Stokes theoreming it up. Arcane compiler, thank you for the follow. I think Floppy pointed out an area where you'd use Monte Carlo methods for machine learning. But I think in general you don't really do that. I think Monte Carlo methods is being used for simulations. And machine learning isn't really a simulation. The primary developer of the method, mathematician Stanislav Ulam, was inspired by his uncle's gambling habits. There's a Wikipedia page just on gambling in general. It's kind of a cool painting. Why does his glove have a hole? What even is this game? It looks like backgammon, but with like a rook / bong on the board randomly with dice too and cards. This feels like if I feel like whoever painted this doesn't know what a board game is, and they just threw together a bunch of things that look kind of like a board game. Okay. Unless we're living in the simulation, that's true. Monte Carlo is used for decay rates in nuclear stuff? Oh yeah, you probably could. Like, oh yeah, I've actually done a similar thing, not for decay rates in nuclear things, but you could definitely use random sampling for continuous time simulations. Because of the exponential distribution, does that exact thing for waiting times. I've done that for, to simulate when a cancer cell splits. You like to go to Monte Carlo? It's probably a cool place. Garshman Kick, if you want to talk about gambling, true, Night Gaspard. Guys, I just discovered this cool website about Counter-Strike cases. You guys should check it out. I want a lot of money. It's definitely not rigged. Threw too many dice. Yeah, Pascal did lots of betting such gaming calculations. Oh, I didn't know that. Probability theory was developed because a French nobleman wanted to know how to settle a game if someone had to leave the table early. I didn't know that either. Backgammon with dice is just... I don't remember how you play backgammon. I thought you said like the little circle things. I haven't played backgammon since I was a kid. I don't know. Ulam was a professor at Harvard from Poland who was called and worked at the Alamos. Like the Battle of the Alamo? Remember the Alamo? I think the Alamo was in the 1800s. I don't know. Los Alamos? I don't know what that is. Manhattan Project? Oh. I didn't know it that this name was associated with it. Um okay, once I catch up with chat, IDK bro, I'll look at the solution you posted. Oh, my stupid Twitch chat. Okay, there we go. I don't know if anyone has this issue, but my Twitch chat sometimes gets stuck at the bottom and I can't scroll up, and it's the most annoying thing ever. Monte Carlo tree search. AIR of the 1800s? Yeah. Heuristic search algorithm for some kinds of decision process. Playing software that plays board games. Solve the game tree. Huh, I wonder how you would use this. Zero adds neural networks. Interesting. Okay, wait. Let me keep reading checks if I'm going to fall behind even more. The Dover book on chance, luck, and statistics by Levinson was my intro to probability. Explains probability through games chance almost exclusively. Okay. Pascal lived during Louis, oh god, the 13th and the 14th. Probably went to Versailles, maybe. Were your stupid Twitch chat? Sorry, Colico. The chat itself, not the people in chat. You did stream on the Manhattan Project? Oh, that's cool. Dude, I've got to do some digging through your YouTube channel at some point. See, you've done streams on all sorts of cool things. HTML files? Why are your solutions in HTML files? You have no idea why chat gets stuck like that? Yeah, it's annoying. My list of people that I follow get stuck too. That one doesn't annoy me as much. I don't scroll on that as often. I don't know how to read this. Like, I'm not Internet Explorer. I don't know why my mind went to Internet Explorer when I needed to name a browser. The snipping tool can open this? What? Oh, to IDK bro. Okay. That's what you mean. Yeah, that's what I was thinking. Like, I don't know if I want to open this. What's this other thing that got posted? Wait, I saw one here. Oh, because here. Oh, okay. That's not a new question. Mark that as done though. Prozac-kun? Thank you so much for the raid. Welcome in, people. I gotta say, I'm not familiar with your stream. Feel free to introduce yourself if you'd like to. If you want to just raid and run, please also do that. For people who are new here, my name is Don. I am an applied math master's student. And the theme of my stream is like will kind of answer your math questions as best I can. If there's no questions from chat, I'll do homework. And we're talking about a few different things right now, but Phobos, hello. Hope you're doing well. And we're about to look at a solution to a problem that IDK Bro posted earlier. Okay, this is better. M2 in the image means method 2. Okay. So the original problem is in the upper left here. I hope your Final Fantasying went well earlier, Phobos. Prozac, you normally stream music. Recently you've been streaming yourself programming in Java, JavaScript, Python, bachelor's in computer science. Ooh, that's super cool. Welcome in. Let me give you a follow back. Thank you for the raid again. What is this? Oh, you have been? Well, thank you. I was thinking your name sounded a little bit familiar. Yeah, IDK bro, I'm also fucked, I think. Is this even saving work? Are we using heart as a variable? That's like a Zach move. DonGPT is thinking. DonGPT is failing. This is not equal to 123. What? The original problem is in the upper left here. I did this problem just the stupid way by plugging the definition of x into this thing here. Apparently there's something different you can do that looks crazy. You know, maybe Winklebot. Sounds good. Prozac. Three plus 2 root 2. Oh god. I don't know how to really draw that, but okay. Okay, you said that this one should be easy for me too, and like this is not I don't know what the hell is happening in this solution. Why is b root 2 an element of the rational numbers? Where do they say that? Talking about that? Oh no, b. I mean, just b is rational. I mean, you can give me another problem. If it's like this, I'm not going to figure this out. You also get 123? That's apparently what the answer is. I got something completely different. Like, I feel like it shouldn't be an integer. Maybe I just did it wrong, but that doesn't... That just feels wrong if that's in such a clean number. Bruh. It's under 23. How? I think you can sometimes simplify. I guess I think you can sometimes fact that as a perfect square. That must be it. And that's what this is. Oh. That's why they're doing this. They want to factor 3 plus 2 root 2 as a perfect square to get rid of the square root. This makes so much more sense. Okay. So, I mean, we don't need to spend more time on this than you want to, IDK bro, but I can just explain why they're doing this first part. I forgot that this is a thing that sometimes happens with problems like this. If you have the square root of 3 plus 2 root 2, this number sucks. This number would suck less if we could rewrite the inside as the square of something, though. Sounds good, Prozac. Thanks for trying that problem, and thanks for the raid. Good luck with your homework. So we can make this number suck less if we can rewrite the inside as the square of something. So I'm making a generic number a plus b root 2 squared, and we want to find an a and b such that this equality is true. Because it just makes the problem easier if we can do that. So if we multiply the right side out, we get a squared plus 2ab root 2 plus 2b squared, or not to be squared. And I'm going to group it by whether they have a root 2 or not. So a squared plus 2b squared plus 2ab root 2. Yeah. And so we now get two equations. I'm going to equate 3 to a squared plus 2b squared and 2 to 2ab. And so that's two equations to unknowns that can be solved. Okay, and so the second equation is easier to work with. We just get, I guess, b equals 1 over a, and we can plug it in over here. Yeah, I forgot. This trick is actually not too uncommon. I just didn't think of it when this problem came up. We can multiply this through by a squared to get a quartic. I mean, I don't like problems like these. I don't find them fun, but I'm willing to do them if it helps people. So don't give these to me just for fun, please. But if you have to actually do them for your homework and you need help with them, then I can deal with it. This equation gives us a equals plus or minus root 2, but we're requiring that a is rational, so we're going to throw this out. This one gives us that a is plus or minus 1, and we have to figure out which one of those is correct to take somehow. This equation tells us b is also plus or minus root 1. So there's actually 4 combinations. I don't know how you figure out which one is right. Do you guess and check? I think they should both be positive 1. Just by guessing and checking. If we have 1 plus root 2 squared, we get 1 plus 2 root 2 plus 2. Yeah. So I just guess and check that. Shoot, I still have a drawing from Color Cone. But let me see what other question. Oh, true. Winklebot, yeah. They have to have the same sign. So they're both positive or both negative. So that immediately tells you they should both be positive because, well, no, it doesn't. What is the difference of 2 cubes? So surely the thing... Like, there's an m squared plus n squared hidden inside of this. I don't know what to do with the rest of this, though. And milk. Sorry. Am I have to join a quantitative finance firm soon? I hope not. I am gonna graduate soon. So all I did was distribute m minus n to these two things grouped together, and then to mn separately. We could solve this for m squared plus n squared. Actually, this is going to be redundant. I don't know. Modular arithmetic? I don't know if that would help. I do want to do your drawing. Color cone. I don't know. Yeah, IDK, bro, I'm fucked. I'm not very good with the type of math that you're like posting about. I feel like you're trying to get at something that's deeper than the surface level of the question. And this type of question, I only know like the surface level stuff. I don't know the tricks that go into these questions. I bet that you're in a country that isn't America though, because at least in America we don't really have to do questions like this. Yeah, $10. Yeah, that's what I have here. One of these is 1? Why is that? Oh. Oh, you're smart. Holy crap. Wow. You're Phobos, you're smart. Say it with conviction. Wow. That's a really that is a good observation. Okay, I mean, the avocado don't. I want to like treat this like a system of equations now, but won't this make them both be 1 at the same time? And we don't want that. They're primes and they differ by 1. So, oh. At least, yeah, in this case. I mean, actually, yeah, 3 and 2 are the only ones that work. Really? Wow. Okay. This is way. This is not as complicated as I thought. You should come back, Phobos. The Twitch world needs you. Like, this is prime math roast material. Um, if you want to math roast me, you like roast away. I don't know how that would work, but I would definitely be open to that. Rate my prime. All right, I guess that's the answer. 68. Fuck. 69. Okay. Color Cone did redeem a drawing. Yeah, and Bobo streams also, so you should go hang out with her if you have more of these. Okay. Color Cone's drawing. I don't know how to draw this, to be honest. Paper color. The book is yellow. Okay, I mean, that's always a good bet for math textbooks. Statistically speaking. Hartshorn algebraic geometry. Hartshorn? Ah. Algeria? No, algebraic. Thanks for the follow, IDK bro. Oh, not copy link, copy image. Yep, classic math textbook cover. At least in like, you can tell that a mathematician made this or like made this cover. It has no creativity at all. See ya, IDK bro, I'm fucked. Felt slightly rusted last week, kept trying to make sense of all the math and keep up. Your chat was like, oh, sweet summer child, close, but no. Oh, yeah, Shane. I thought I had done a decent job of preparing to give that talk, and I kind of didn't. And so yeah, the chat was pointing out some really like good things. I don't know, but yeah, you might be right, and I should just like prepare less, and that will be better. The book kills so many people interested in algebraic geometry how awful exercises are. Oh, okay. I don't know how Destin looks, so I'm just gonna guess. Destin definitely has green pants. I think we can all agree on that. That's nice to hear, Shane, but I don't think you were slow. You were you're doing a good job of explaining the stuff that I was like fumbling with. You might be right, Winklebot. This was the first thing I found on Google Images. I don't know though. Dustin wears a leather jacket. Ooh, I like that, Fembox. Imagine like brown leather. I don't know. So, I mean, I don't know how to draw the shininess, but maybe just a plain poop brown is good enough to be a leather jacket. Oh wait, he needs to be a Giga Chad. Okay, he's gonna be a Giga Chad where he's gonna be wearing a leather jacket but not a shirt underneath it. And he's gonna have some wicked abs. He needs a collar, right? How do collars look? Wait, do leather jackets? No, they have zippers, right? You know, that's gonna look weird. Let's not draw that. Okay. Actually, no. Destin definitely has an 8-pack. Magician learns neither early or late, but precisely when they mean to. Gandalf, probably. Little collar button on the top. Oh yeah, yeah. It's kind of a thin neck, but oh well. Oh god. Aviator sunglasses? Ooh, yeah, yeah. Oh god, how do I draw aviators? I need to look up an image. Aviator with a goddamn jet. God, dude, this guy is so cool. He has a leather jacket and aviators. Like, okay. Guitar picks? Oh, yeah, yeah. I don't know if they're coming across quite right. Uh, kinda. Nailed it. He has a nose. He's smiling. Probably has hands. I would bet Destin has hands. And also, I just think about how I was criticizing the painting I was looking at on Wikipedia a while ago. I definitely, I definitely have the high ground here to criticize art. This one has orange shoes. for sure. It's 1% of his body size. Yep. Okay, yeah, you're right. We can make the head a little bit bigger. Slightly better. He needs to have some cool hair too. Bigger feet than head. Hey, you know what that means. He's have cool swoopy bad boy hair. I don't know if that's it. Do I try to shade this in? I feel like I'm gonna make it worse if I try to shade it. Service motivation for it. Yeah, big socks. I don't know. Oh wait, we need to draw the actual book. I forgot all that. Um, doing chapter 2 exercises. Okay, he needs a desk. Um, it's gonna be a desk that's tilted up so we can see what's on it. Let me get a, I guess that's a good enough yellow. Just little squiggles. Can't quite read that text. Saddle chair or a yoga ball? Nah, he has a standing desk because I don't have. I already don't know how to draw someone standing. I definitely know how to draw someone sitting. Most of the chapters left as an exercise. Classic. I guess he needs to have something to write with. Um. Wait. No, why did I do that? Okay. Is this good enough? I don't know. Publishing with is an exercise to the student. Hey, skirt. Don't you choose to be critical than to be correct. That's true. Although I feel like the fortune cookie is kind of throwing shade at you by telling you that you're always correct. Okay, I might call this the drawing. You know, I feel like maybe I could shade in the color, the collar. That might look better. I don't know. It probably looks worse. Don't know if it's good enough done. Are you happy with your work? Are you proud of what you've done? Oh God, Shane. I'm never happy with anything I've done ever. It's a problem. I'm calling this good enough, I guess. Put this in the loop. Yeah, right next to my husky drawing. All right, thanks for the redeem, color cone. Okay. Yeah, it's posted already. Okay, I don't want to stream for much longer, but maybe we can at least get a start on this problem. Um, there's a fly in your nose. Watch out, Zach. I should stream repo so it balances out. I don't know, Skirt. Oh, yeah. I could, but it's nice to kind of chill. Wait, this must be a typo. Wait, surely this is dy, right? Where's my notebook? Uh, oh yeah, apparently this formula or a version of it was made by Kirchhoff, who I thought only did stuff with circuits, so that's the only area I had heard of him. Wrap up application of Taylor polynomials. Calc 2 is done. We didn't test applications. Sounds good, Winglebot. Thanks for hanging out. Okay, so let, let's recall where this capital U comes from. So we talked about it in class. We start with the wave equation with small u in Rn. Okay, it is dy. That's a typo. Let me finish writing the set of though. Oh, God. My professor is so inconsistent with his notation. Hey, TVSR. Okay, so we're artificially defining this function capital U. That is the spherical mean. U, Y, T. And we said D sigma Y. But this sigma Y should just be like this T should be a Y. Your birthday in 30 minutes? Ooh, happy nearly birthday. That's awesome. What is the Euler-Poisson? Oh, okay. And so the Euler-Poisson-Darboux EPD. UTT URR. Read it in 30 minutes. So we need to prove this bad boy satisfies this thing. I think capital UTT should be easy. I think it's just this. Because the integral is in y. Doesn't care about time. For URR, we're going to need some type of fundamental theorem of calculus thing, I assume? Question mark? Do I need to actually parameterize the surface? I don't know. I think the professor says the book goes through this calculation, though. Yeah, this is a kind of a cool physical interpretation, which is it represents how, like, you can think of sound as evolving in concentric spheres. And this capital U function kind of captures that. Wait. Theorem 2, oh god. 2.2.2. Theorem 2. Theorem 2. Okay. So we're taking the derivative in R of a mean value integral. Ah. Really? Oh, yeah, you do a change of variables. True. Using Green's formulas. Okay. Okay. That's not so bad. R over N BXR delta U. Ooh, there is a subtle... This is just dy now. It's no longer dsy. Why is that? Oh, wait, now it's an integral... Ooh. Oh. Oh! Okay, I think I understand. Because of Green's theorem. It's no longer... Yeah, because Green's theorem turns the surface integral into a volume integral, right? And discover after some computations... Ugh. We need to actually do these computations. This looks like possibly the result of integration by parts. Because there's a boundary term and a volume term. we'll probably need to do the same change of variables. So if I take right now I'm studying partial differential equations. I'm working on the wave equation right now. Y equals x plus rz. Oh wait, is this the Laplacian? What? It's the Laplacian isn't in T, is it? Oh, which course did I what is CLG? College? Oh, okay. I majored in applied math, minored in computer science. I think this Laplacian is in Y. Or I guess in X. In Z. Yeah, because X is the center. Don't we probably need a chain rule though. Like we need an R squared. Iced Lemon, thanks for the follow. Or is it R to the N? Wait. Ice Lemon, this is homework from a class that I'm taking on partial differential equations. I'm trying to calculate something with the wave equation with D'Alembert's formula. If you have a question or something you want to talk about though, please do let me know, and I'll talk about that. I'm getting towards the end of the stream, just as a warning though. Oh, awesome. Thank you so much. If you don't know, this niche, like, it's not just me who streams math on Twitch. This is the kind of list of people who I generically recommend. It is kind of a long list. People who are streaming the most actively right now are Actual Education, Ian Stuckey, e to the 2I pi, and Ensimplex Pachinko, I think are the most active people recently. Everyone else kind of like goes through phases of streaming a lot and only streaming a bit. But yeah, I really want to grow this niche also. There's a really cool community of people that we have here, so I really encourage you to, if you're interested in stuff like this, to kind of do the rounds and check everyone out. But yeah, so the theme of the stream is I take questions from chat. I'll do my best to answer them. A lot of times I can't, but I'll always try. And then if there isn't a question from chat, which happens often because this is a small niche, um, I pull questions that just like from my homework, because I'm an applied math master's student. And so when I'm not busy being a grad student, which I haven't been a grad student for that long, but I have done things like reading groups where I'll get in Discord with anyone who wants to like participate and read along, and we'll just like study a topic together. Itsu Pai, or Zach, he's done actual like classes on Twitch. Like he's done 2 real analysis classes. He collaborated with Penn Center on a linear algebra class, and I think I'm forgetting one. You suck at differential equations? If you have any questions, like let me know. The differential equations are awesome. Oh, it's awesome to hear TBSR. They're like, if you've only taken an introductory differential equations class, that I think is a notoriously kind of poor way to learn differential equations. Or like it, you're not learning the thing that makes them actually cool and helpful. Took a real analysis class in college and you struggle with them. Oh yeah, definitely. If you're learning about the theory of them, that's even harder. Can you work in an aerospatial agency like ESA with a math major? Probably. I mean, almost certainly, because I'm like, if nothing else, okay, if you're doing pure math, that might be a little rough, but if you're doing applied math, like, you're gonna be good with writing simulations, and I'm sure that ESA and NASA and people like them need a lot of simulations. And I bet they also need people to just do like direct like computations too. So I would bet the answer is yes. I don't know from experience, but yeah. Professor's nice way out of our league who was flying through problems while we were stuck on basic stuff. I really hate that type of professor. My professor for this class right now is kind of like that, and I spend a lot of time just ranting about him. Why is this Z times DZS of Z? Shouldn't it be R? It's confusing. I know I'm getting kind of like mentally tired. Number 4 at least say. Ooh, that's kind of fun. I bet I can do this. Can I do this? Maybe. I want to try. So, which one do I want to start with? It's constant in time. So, I think... Oh, wait, okay. I think the thing we want to show is that k prime plus p prime is equal to 0. So, the integrals are with respect to x, so the derivative in time can come right inside. That's what she said. 2ut chain rule utt xt dx plus integral over r 2u x xt uxt. Ooh, we get a mixed partial here. So the fence is weird. It is weird, skirt. Oh shit. Are we gonna start soon? I haven't been looking at the Discord. Oh god. Okay. I should really cut the stream off within a few minutes here, but I want to do a little more work on this. You'll hold the door, skirt? Thank you. Might be a weird question. What are qualifications? Somebody needs to be an astronaut? I don't know. Hodor. Thank you, Iceland. I appreciate that. Oh, NASA has a page on this. That makes perfect sense. Well, I want to know the qualifications too. Now I'm getting distracted, but I'm really curious to look at this. Be a U.S. citizen. Master's degree. Really? It's interesting they require a master's degree. Okay, or work experience. That makes sense. Oh, a test pilot. Wow. Minimum 3 years related professional experience. What is a related professional experience to an astronaut? I guess a pilot? Okay, yeah, that's fair. Or be a medical doctor, which is really funny. Like, I don't know. I feel like real fish out of water if I, as a medical doctor on a spaceship. Long duration flight astronaut physical. Huh. I wonder how many applicants they get. Probably a lot. Yeah, I'm sure they need to be physically strong. That's crazy. Okay, we know that UTT is equal to UXX. Is that helpful? I would never, you could not, there's no amount of money you could pay me to put me on a spaceship. Miss me with that. This looks like something. I don't know what, but it looks like something. Does this they do insane? I wonder what they're like. Professional experience to the STEM degree awarded? I think they mean like being a pilot or a medical doctor. Being oh yeah, I think so too, Zach. It's still just kind of funny. I don't know that most of them are about being a pilot, but then you just get thrown in there as a doctor. You have no choice though if you need to be in a spaceship. That's true. Yeah. Hopefully I don't get Project Hail married. I mean, he was a biologist at least though, so I don't think they're going to need an applied math person in space. You love to go to space? Space? You love to fly a plane? I would not love either of those things. I never used to be a nervous flyer, but the last like maybe 2 times I flew, I was really nervous. I don't know why I became one. Amaze, amaze. I've only read the book. I still haven't seen the movie yet. I have a friend, like I'd never heard of this before my friend told me about it, but he streams I mean he doesn't stream surf much anymore, but he's been streaming like Deadlock. But he as a hobby, he flies like planes without engines. Like you're literally in a thing in like a glider, and you just get like slingshotted forward super fast, and you glide around, and that's his hobby for physical requirements. Yeah, I need to see the movie because the book was really good. And the reason I read it's because a streamer friend was doing a just like a reading group. It kind of like I think she got busy with life and we stopped like meeting, but it was a nice way to like read books that I wouldn't normally read. Have a good heart. Okay. Bone density, full range of motion, core strength. I want to know like how much do you have to bench? That's what I'm looking for. VO2 max? I don't know what that means. Okay, fine. I'm not seeing the exact thing that I wanted. Wait, you have to be a certain height? Huh. 62 inches, 75 inches. Okay, that's most people are between those, right? Okay, anyway. You're halfway through the book, the science is also lacking? Really? I remember it having some science. Like it's never gonna be that technical, but it was kind of sciency. There's very little I love more than studying how to operate a big, expensive, dangerous machine than to operate that machine. You know, fair enough, Phobos. What kind of machines do you know how to operate? I think Rocky said it in the book too, but I've heard other people referencing that same thing, Shane. Mostly Skirtle. So that I do know the reference. Capsules are fairly small. That makes sense. Donald Trump would easily qualify. Everybody knows. It's like at trying to fly helicopters. I'm better with light planes. Some medium-sized things for moving the Earth. I mean, that's kind of cool though. Like the claw thing. And Skirtle's probably about to annoy me again with it in a few minutes. Really big and complex computer systems are similar. Okay, okay. Yeah, like big servers. The music just stopped, by the way. Um. Okay. To be fair, I don't know how to progress from here. Maybe we integrate by parts. The mixed partial derivative is what's throwing me off. I don't know what to do with that one. Maybe there's a way to write it as a product rule or something though. Like I feel like there's got to be some sort of trick. You have to notice this is like something. I don't know what, but something. Um, I don't know. I should probably end the stream though. Let me save this. Um, Scratch work. Okay. YouTube stream will get cut off here. And it's here on YouTube. Thanks for being here. On Twitch, we'll look for a raid.